everyone. Today, our lesson is a continuation of the one that we've discussed before, that is finding the leading coefficient or using the leading coefficient test as well as finding the real zeros of the polynomial in order to sketch the graph of a polynomial. So here, I'll give you guidelines for graphing polynomials, but the lessons that we've discussed already can still be used in these guidelines. And I will also be talking about intermediate value theorem, but this one is very short. So here, we have sketching graphs of polynomials or guidelines in sketching graphs of polynomials. So first is to apply the leading coefficient test. So assuming that uh, we knew already how to use the leading coefficient test, that is, we have to identify the degree of the polynomial first, then identify the sign of the leading coefficient. Okay, if it is positive and the degree is even, then it starts from the northwest going to northeast. If the leading coefficient is negative, then it starts from southwest to southeast. Okay, if the degree is odd, it starts and the leading coefficient is positive, then it starts from southwest to northeast. And if it is negative or the leading coefficient is negative and the degree is odd, it starts from northwest going to southeast. Okay? So after that is we have to find the zeros of the polynomials. How to find the zeros of the polynomials? We equate the given function into 0. Then you solve for x. Okay? But those leading coefficient tests as well as the zeros of the polynomials are not enough to come up with a graph which is almost exactly the same of the graph if we will be using a software. So we need to have additional points. Okay, so next is after plotting additional points, that's the time we can draw the graph. Okay, so we have here an example. Sketch the graph of f of x is equal to 3x raised to 4 minus 4x cubed. Okay, so apply the leading coefficient test. Identify what is the degree. The degree is 4. And the leading coefficient is positive, right, which is 3. So we expect that the behavior of the end behavior of the graph is rises to the left and to the right, or from northwest going to northeast. Okay? Then find the zeros of the polynomial. How to find zeros? We equate this one to 0, then we solve for x. But we have to factor this out first. So by factoring, we come up with x cubed times quantity 3x minus 4. Thus, by 0 product property, x cubed is equal to 0, then x is equal to 0. 3x minus 4 is equal to 0, then x is equal to 4 over 3. Therefore, the zeros of this polynomial is x is equal to 0 and x is equal to 4 over 3. Okay, note that x cubed is equal to 0, which means it has an exponent 3, so of multiplicity 3, and x is equal to 4 over 3 of multiplicity 1, because the exponent of x minus 3x minus 4 is 1. So they are odd multiplicity. So both of them are of odd multiplicity. So next is we have to plot a few additional points. Now, how to plot or how to get few additional points? So we start finding the additional points from the x-intercepts. Note that we have x is equal to 0 and x is equal to 4 over 3, right? So from here, we can create intervals. So if we are talking about the numbers in the real number line, so we can have an interval from negative infinity to 0. So these two here become the boundaries. So negative infinity to 0, one interval, 0 to 4 over 3, another interval, then 4 over 3 to positive infinity, another interval, to form a uh, to form a values in the real number line. So we have here table. So first, create intervals. So this is negative infinity to 0, 0 to 4 over 3, 4 over 3 to positive infinity. So once you have already the intervals, that's the time you select one representative, a number that belongs to that interval. Let's say x is equal to negative 1. So since negative 1 is in this interval, so this is our representative. The interval 0 to 4 over 3, we select the representative which is 1. Then 1.5 as the representative of 4 over 3. Then we get the value of the function f. How to get the value of f? So we need to substitute our representative to the given function. So by substituting negative 1, so this becomes 3 times negative 1 raised to 4. So negative 1 raised to 4, okay, is 1 because the exponent is 4, which is even. So negative 1 times negative 1 times negative 1 times negative 1 is 1. So the result of this is 3 times 1 minus 4 times negative 1. Now negative 1 raised to 3 is just negative 1. Then this will be multiplied to negative 4, so this becomes positive 4. So 3 plus 4 is 7. Okay, now the same with 1. So if we substitute 1, we must get the value of the function, which is negative 1, and so on. Then after that, we identify the sign. So the sign of 7, it's positive, and this is negative, and this is also positive. So from here, from the x representatives and also the value of the function f, we have the point on graph or the ordered pair. So we have negative 1 and 7, 1 and negative 1, and 1.5 and 1.6875. So in other words, we expect that the graph starts from what? From the northwest going to northeast, then it touches the point x is equal to 0 and x is equal to 4 over 3, right? Because these are the intercepts. And also, in the points negative 1 and 7, 1 and negative 1, 1.5 and 1.6875. So draw the graph. So the graph is this. So we plot the, okay, our expectation is correct based on the end behavior using the leading coefficient test. So it starts from here, then it ends here, from northwest to northeast. Then the x-intercepts are 0 and 4 over 3, which is 1 and 1/3. So here, this is 1 and 1/3. Then plot additional points, negative 1 and 7. So negative 1 and 7, this point here. And next is 1 and negative 1. Where's 1 and negative 1? This is 1 and negative 1. And next is 1.5. This one, 1.5 and 1.6875. Now, you may ask, Ma'am, where did you get this point? Actually, you can add additional points if you are not sure of the shape of the graph. For example, from here to here, okay? Maybe you can create a line or a curve, right? So to be sure, you can select another point in between 0 to 1. Okay, so this point here. So for example, this is, you try For example, 1/2, then you substitute 1/2, then you will have the value of the function. Okay? Then you connect all the points. So connect all the points. Okay, so that's the graph of f of x is equal to 3x raised to 4 minus 4x cubed. Okay? So that is how we graph a polynomial using leading coefficient test, finding the real zeros, and also um, plotting additional points, okay, using the x-intercepts. Then you create the intervals and you select representatives in that interval. Then you substitute the representative to the given function, find the sign, and have the points on the graph. Okay? So here we have the intermediate value theorem. This is very short. So the theorem states that let A and B be real numbers such that A is less than B. Let A and B be real numbers such that A is less than B. Okay? A is located, okay, here. So this A is less than B because it is in the left of B. If f is a polynomial function such that f of A is not equal to f of B, okay, such that if we have a polynomial function such that f of A is not equal to f of B, then in the closed interval A and B, f takes on every value. So f takes on every value between f of A and f of B. So for example, there are points here, right? In between A and B. So we can have, let's say, 1 point only. So C. So we can have f of C, which is equal to D, for example. Okay. Now note that f of C is still in between f of A and f of B. Okay. So we are done with intermediate value theorem. It's just a theorem, so you need um, to familiarize only the theorem. So here is an exercise. So if you want to practice more on graphing a polynomial function, use the guidelines on sketching a polynomial function. So if you want to know if your answer is correct, so you can show your answer in the comment section and I'll give feedback on about the answer that you have posted in the comment section. So first is sketch the graph of the function g of x is equal to x raised to 4 minus 9x squared. First is apply the leading coefficient test. Second, find the zeros of the polynomial. Third is plot sufficient solution points and draw continuous curve through the points. Okay, so this is your exercise. Hope you can do this. And thank you so much for watching. Hope you learn something from this video and do not forget to share the learning that you've got from this video. Thank you once again and God bless.